That is a time. Oh, wait, I don't like that. Change that.
Keep the time.
Okay. When you see problems like this, we've always talked about if you have the same thing on the bottom as on the top, you can cross cancel them. So a lot of people think that because there's a 6 here and a 6 there, that you should just be able to do this. You should just be able to say, oh, 6 on bottom, 6 on top, my answer is 12. That's not true. Okay? That's not true because here's the key. In order to cross out bottoms with tops, they must be factors, not add-ins. These are two things added together, not two things multiplied together. Okay? So, you know what the answer should be. It's 6 plus 12 is 18 on top, 18 divided by 6. Your answer should be 3. Okay? So if there's some way that you can get the top to be factors, something times something to give you something, then the 6 would cross out. In other words, I'll do it with this even though you don't see it with numbers very often. Now, if I were to take something out of both of these, what's the greatest common factor of 6 and 12? 6. So I could factor out a 6 on both of them. If I take a 6 out, I'm left with a 1 plus a 2, right? Take a 6 out of a 6, I get a 1. Take a 6 out of 12, I get a 2. Now, these are both factors, and I could cross off the 6 with the 6. And my answer would be 1 plus 2, which does equal 3. It'll make a little more sense when there's letters there, because there's no reason you would do this in this case, because you could just add it. Okay, yeah. But it's going to look like this, straight up out of the book. It'll look like a problem 6x plus 18 over 6. Oh, look at that. Okay. You are not allowed to just cross off this 6 with that 6, or even this 6 with that 18, because these are not factors. So that's why we talked about factoring them. You can make them factors by taking out what you can out of both of those, which would be a 6. If I take a 6 out, I'm left with a x plus a 3. And now because this is this times this I can cross off with that because this is a factor of 1, I guess, and that's across. And you just have an x plus 3. By the way, the only way to get an x plus 3 to cross off, yeah, that's all you can do. The only way to get an x plus 3 to cross off would be if there was an x plus 3 on the bottom. Okay? If I have this x plus 3 over x, you can't do anything with that. Even though these are both x's, because this is already factored out as far as it goes. You can't take anything out of both of those things. You can't make these factors. It just has to be what it is, even though you say, well, there's 2 x's there. It doesn't matter. Okay? Unless it's factors, unless it's multiplying, you cannot do that. Ava?
Couldn't you just divide each of the?
You could, although I don't necessarily recommend that. You say, yeah, I can take 6 into that and 6 into that. Yeah, you could rewrite this problem actually as 6x over 6 plus 18 over 6, because that's really what it means.
Yeah.
Okay, but this is really going to be the way. Ava, this is really going to be the way that's going to be easiest for you. You could do it. I'm not against it. Let's look at a little more complicated one. 18x plus 45x cubed over, I believe it's 9x.
Yeah, that's, is that cubed or squared?
Cubed at the end.
Wow, this is fun.
Okay. Again, you're not allowed just to take the 9x into either one of those things because they're not factors of anything. Okay, it has to be all multiplication here. But you can look at this and go, okay, what can I factor out of both of those? Well, higher. 9. They always try to make them kind of work out. So I would think 9 first. If you take a 9 and a x out, because they both have x's, factor that out, you're left with a 2. 9x times 2 is 18. 9x times what is 45x cubed? 5x squared. Okay. Now these two are factors of each other, and this is a factor. There's no addition sign there. So you could cross off this and that, and you're left with just that. If, let me just throw this at you, if you factor it out and you get this, and you end up with this, sorry,
Wait, what is the second?
what's who?
Is it 12 or 2?
Which one? Two?
It's 2.
Two?
2.
Two? Two?
Yes, it's just.
I just wanted to throw this at you, this didn't come up in this one, but it might. If this was your top, like we factored it out, and it was just 3x on the bottom, could I simplify or do anything with that?
No.
Yes, I can.
Oh, yeah, shows nine.
In reality, if you wanted to split this up as factors as it could be, you could separate, that's the 9, it's times x, times 2 plus 5x squared. Those are all the factors on the top. Just because I put the 9 and the x together doesn't mean it has to be one group. Same thing on the bottom. This is 3 times x. So these x's are both factors, you could cross that off. You could take the 3 into the 9 because you can divide 3 into 9 and you get a 3. So your answer would be 3 times 2 instead of 3 times 2 plus 5x. It takes a long time to kind of get used to this. It's really something that people struggle with quite a bit. I'm going to give you one more just because I can. 3p plus 3 over 3.
What?
3p plus 3 over 3. Tell me what you simplify that down to. 3p plus 3 over 3. P plus 3 over 3. Not necessarily a hard one. What are the ones that were more difficult? I should have you look at lesson 39 and look at some of that stuff. It's, if I had to say my least favorite stuff to do, it's lesson 39. In the entire world, huh? Skip it. And really I could.
That's what.
It looks impressive when you do it, but it's. Just cross it off. Zach Rice, you ended up with?
P plus 1.
Correct.
Dang.
You factor out a 3, you're left with p plus 1.
Why isn't it? I did it! Well, yeah.
Because when I take a 3 out of this, I take a 3 out of this, and I take a 3 out of that. 3 goes into 3 one time. You're factoring it out. The 3's cross off, and it's just p
Finally,
plus
do
1.
Yay, something clicks.